Welcome to ClickMyProject.com. And this is our title, Learning Based Regularization for Cardiac Strain Analysis via Domain Adaptation. And this is our abstract, Reliable Motion Estimation and Strain Analysis using 3D and Time Echocardiography for localization and characterization of cardial injury is valuable for early detection and targeted interventions. However, motion estimation is difficult due to the low SNR that stems from the inherent image properties of 4DE. 4D means dimension echocardiography, and intelligent regularization is critical for producing reliable motion estimates. We incorporated the notion of domain adaptation into a supervised neural network regularization framework, a semi-supervised multi-layer perceptron network with biomechanical constraints for learning a latent representation that is shown to have more psychologically displacement. We extended this framework to include a supervised loss term on synthetic data and showed the effect of biomechanical constraints on the network's ability for domain adaptation. And this is our flow diagram. First, start our project, then select our dataset. Dataset means echocardiography to use it in our base paper, and then view our dataset, and then data preprocessing. Data preprocessing is a data cleaning method to use null values or empty values to remove our dataset, and then model selection. Model selection means to split our dataset, train dataset and test dataset. Ratio means 70-30 or 80-20 to split our train and test dataset. And then classification. Classification is two algorithm using our base paper. One is MLP. MLP is existing, and then CNN. CNN proposed our algorithm. MLP means multi-layered perceptron, and then CNN is convolution neural network. After complete this classification process, going to result generation, accuracy, precision, recall, F1 measure score. We start our project. First read dataset. This is our dataset, and then count different values in target. There are two values in our target values. Then check null values. Null value is true. These are attribute in our dataset, and then check overall column. After remove null values, this is our dataset, and then again checking null values, false, and then count plot graph. Count plot graph based our target columns. 0 is 67.4%, and then 1 is 32.6%, and then splitting our dataset. Ratio is 70-30. These are independent attributes, and then these are our target attributes. After this process, implementing algorithm. MLP is multi-layer perceptron using our existing algorithm. There are 23 iteration and losses, and then accuracy is 62.5%, and then precision, recall, F1 score, and then confusion matrix. Confusion matrix based our accuracy in MLP, and then CNN. CNN means convolutional neural network. This is our proposed algorithm. To predict our accuracy, is 87.12, and then precision, recall, F1 score and this is confusion matrix based our accuracy in our CNN algorithm, and then overall to compare accuracy comparison MLP and then CNN.